Welcome everyone to this video where you are going to learn about bitwise operators in Python. They are actually quite similar to the logical operators, but at this point we will learn to actually perform the operation on each bit separately, and let's take a look how we can actually do that. So for example, we all know that each number that we have can be represented in binary as well. For example, we can have a number as 5, and we can have another number as 3. So let's say x is equal to 5, y is equal to 3, and I'm going to represent them in their binary representation. So 5 in binary representation will be looking like something like this: 1 0 1. And just for a standard, let's say that we are just looking at 4 bits each, so I will add 1 0 on the left to make it a 4-bit number in binary. And in the similar way, we have the binary for y, which is value 3 1 1, and I will just add 2 more zeros here. So these are actually the representations in binary for x and y. And now what we will do is we are actually going to perform some bitwise operations. Remember, in the bitwise operations, they are performed in between each bits. So here this one is a bit, this other one is also a bit, so each digit in binary is represented as a bit. And if we have 8 bits, then we call that 1 byte is equal to 8 bits. So each bit have this operation in between them. So let me just write it a little bit larger here: 0 1 0 1 and 0 0 1 1, and this is x, this is y, this was the value 5, this was the value 3. And now if we want to do a bitwise AND operation, which is represented as this, so what will happen? We will take AND of this, then we will take AND of this, AND of this, and AND of this. So we know that for an AND operation, both values should be true. So 1 and 1 both are true, so the result will be 1. 0 and 1 both should be true, so then only we can have the result to be true for AND, so this will be false. 0 1 and 0 both should be true if we are doing AND, so this will be 0. Both are zeros, it will still be 0. So this is the output of bitwise AND operation. In the similar way, so let's call it this way, let's compute the bitwise OR operation, and I say bitwise OR. I just wanted to change the color. Okay, now if we do the bitwise OR, now what will happen? Looking at this way again, if we are doing bitwise OR, what will happen? 1 and 1 both are true, so we will have 1 0 and 1 of them should be true. For OR, either of them should be true, so this will still be true. 1 or 0, for OR either of them should, either or one of them should be true, it is still 1. And then we have 0 0, both are false, so this is the result for OR operator, which is bitwise OR. We already have these examples here as well, so we will check the code as well. And now this, if we convert it into a number system, a decimal, so this representation will be 7. It's very easy to convert binary to decimal and decimal to binary. You can look on your favorite search engine and you can find it. You can ask any other AI tools to actually explain it to you. It's very easy, so I'm not going into that detail. And if we also go ahead and convert this one into binary decimal, this will be 1. So in this way we have these two representations in decimal for these binary representations. And then if we actually go into the code for these ones, it's very simple and it will actually give us more insight on that. Over here you can see we still have this x equal 5, y equal 3. Let me erase the output of this one so we can actually look at it again. And we are performing these bitwise operations. So we have this AND, which is bitwise AND to perform an AND operation between each bit, bitwise OR to perform the OR operation between each bit, and similarly the XOR operation, the negation or the bitwise NOT operation, bitwise left shift and bitwise right shift. I will also explain what these operations does. So if we check here, you will be seeing x is assigned a value of 5, and we know that x has a binary value which we have seen. Y is also having a value of 3, and then we will be now performing this bitwise operations, x and y for example. And now we have also used a binary function which is a built-in function. So you can see that the moment I bring my cursor here, it says return the binary representation of an integer. So this bin is similar to a print function where we were passing a value inside the parentheses for a print function and it was printing it. Here we can specify any value by writing bin, writing a parenthesis, writing any value, closing the parenthesis, and it will return a binary representation of that result. So when we are performing a bitwise AND between x and y, the result will be printed in decimal, but just for clarity, I'm also printing that result in the binary representation as well by just adding a comma. So here I'm computing the bitwise AND, and here what I'm doing, I'm converting the bitwise AND into a binary representation. Similarly, here we have this bitwise OR, this is XOR. Oh, and XOR is also an operation. So both values should not be same for the output to be true in case of XOR. So that you can actually check, and if both of them are not true, both of them are not same actually, then the XOR will have the output to be true. Otherwise, if both are same, either both are 0 or either both are 1, the output will be 0 for XOR. And for NOT, bitwise NOT, it will invert all bits actually, 0 to 1, 1 to 0. And for the left shift and right shift, it actually adds zeros towards the right for the left shift, or by moving the digits, or in case it is actually right shift, it will add an extra 0 on the left and will move it towards the right. So I will even demonstrate this thing in the slide as well. So let's just run it first. Okay, so we have actually executed this part, and now what we are going to do is we will see that bitwise AND result is 7, and I remember that we also have this bitwise AND result. Oh, I have a mistake here, that when I was writing it, I was supposed to write it as AND. So let me just correct this one. So this was AND actually, and for AND we have the result to be 1, and for OR we have the result to be so over here you can see for AND we have result 1 in decimal, and then for the OR we have result in 7. For XOR we can also confirm this thing from this example as well. So if we want to do XOR actually, XOR, which is bitwise XOR, let's do it here. You can see that I mentioned earlier that both of them should be different to have the output to be 1. So if both of them are actually same, output is 0. Both of them are different, output is 1. Both of them are different, output is 1. Both of them are same, output is 0. 0 1 1 0, which results into 6 in decimal. And if we come here, we will also see that for the XOR, this was the symbol for bitwise XOR. If you check here and the syntax, and it has this result of 6. Similarly, if we go to for negation of x, and for negation of x, we can even see, I can write here not. Okay, where should we write not? Okay, we can write not here actually. And we are doing it for x actually. Okay, so 0 to it will be converted into 1, 1 will be converted into 0, 0 will be converted to 1, and 1 will be converted to 0. That is the inversion of bits. Internally what will happen, that it will invert all bits. And remember, it will not invert only the 4 bits, it will invert the complete representation of this, and the final result will be -6. And when we actually have it calculated here, you can actually see that is some decimal to binary conversions that you can look into. I'll not go into very much detail for that. And then we have this left shift and right shift. So in the left shift, what will happen, we have this x with value of 0 1 0 1, and when we perform a left shift, we shift the digits as many times we want to shift it, and add zeros on the right. So let's go back in the example, and we have x to be like we can add a new slide actually for this left shift and right shift, so we understand it properly. I'm gonna add a blank slide with that, and now I will say left shift. Again, x is equal to 5, and when we represent it in binary, we have the value represented it as s 0101. Now we want to perform a left shift. In order to perform a left shift one time, for example, if we say just perform the left shift as we want to do here, and we go back, this is left shift, and we want to perform it only once, so the output will be like in this way, that the very first digit, because we want to perform only one left shift, we will drop this one, we'll have output 101, and we will add a 0 on the right. So we will drop the digit from the left as many we want to shift, and add zeros on the right. Okay, that is the result of left shift. And if we go back in our code, we can also see that this is what we actually were able to see as result of 101 for left shift. Similarly, we will go and try it for the right shift as well. Let's go back and try it for right shift. Now for right shift, again we have the same x, and we want to perform the right shift actually. What will happen for the right shift is that we will be actually removing the digits from the right and adding zeros on the left. So it will be moving in this way, where we have these let me just write 0101 here for understanding. So we need to actually remove digits from the right. So we have this output like this. So in this way, we will be removing digits from the right. We only need to remove this one, so this one will be removed, and it will become 010, and we add digits on the left, we add digit here. So you can see this is how we have this output here. Now we have an understanding of left shift, right shift. Right now you may not see clearly where these applications will be used for bitwise operations, but really they have a lot of applications in masking, filtering. When you are deep into the development and data science, machine learning, there are a lot of applications for these. So please stay with me, keep learning, and you will learn how to actually utilize all this information. Please do practice for all of these stuff that we have learned. Take a look at them, practice them in Google Collaboratory, and I'll see you in next video, where we will actually learn more about some other things, including the taking user input in Python. Okay, I'll see you in the next video. Till then, have a good day. Bye.